Hello, good morning, good afternoon, and good evening, everyone, from the World Resources Forum. This is a scientific session of the World Resources Forum in 2025, titled Measuring and Advancing Circularity from Global to Local Perspectives. My name is Emanuele Di Francesco. I am the Senior Manager Communications and Partnerships of the World Resources Forum, and today I will be moderating this session. I have the pleasure to have here with us Roland Weber, who is from POP's Environmental Consulting Germany, Namia Sharma from the Indian Institute of Technology, Bombay, India, Luciana Contador from CETEM, Brazil, Luciana Moffati from the State University of Rio de Janeiro and CETEM, Brazil, and Shiza Aslam from Leiden University, the Netherlands. Presentations will be in this order. I ask everybody who is in the audience to please feel free to put your questions either in the chat or in the Q&A panel, and then these questions will be picked up either after the individual presentations or at the end of the sessions. Without further ado, I would like to give the floor to Roland Weber, who will be the first presenter of today. Please, Roland, the floor is yours.
Yes, good day, everybody. So my presentation will be promoting circular economy by supporting countries with baseline data within multilateral environmental agreements. These are conventions, for example, for plastics, for POP, persistent organic pollutant additives, and resources in major product sectors. Presentation is together with Keith Balde from UNITAR, and he's also from the Global E-Waste Statistical Partnership. So when we move from a linear economy to a circular economy, hazardous chemicals need to be controlled. For example, a range of hazardous additives, including persistent organic pollutants, are in certain plastics and can be transferred here by recycling, resulting in exposure, for example, when you recycle e-waste plastic and finally produce toys out of it. Here I would highlight two publications, one Haladakis 2018 and also the UNEP report on chemicals in plastic, which shows these challenges. So a range of data on international regulated chemicals, including persistent organic pollutants, but also mercury, ozone-depleting substances, and greenhouse gases, are generated within major multilateral environmental agreements, such as Basel and Stockholm Convention, the Montreal Protocol, or the UN Framework Convention on Climate Change. My main work the last 20 years was supporting countries for Stockholm Convention development. But data generation is often not coordinated within a country. So to better coordinate the generation of robust data, two guidance documents were developed within the Stockholm Convention. Actually, I developed these two guidance documents here on POPs to promote harmonized gathering of data for sectoral inventories of electrical and electronic equipments and related waste, the transport sector, and for building and construction sector. So here, one time, this guidance on sectoral guidance for inventories, and the other is guiding methodologies for strengthening collaboration with national statistical offices. For both of these guidances, you have here the link to webinars which are introducing to these guidances and to the approaches. Because a major share of industrial POPs, this include brominated flame retardants like PBDEs, HBCD, but also other plastic additive, dechlorant plus, UV stabilizers, UV328, short chain, medium chain chlorinated paraffin, is today included in electronics, in transport and building and construction sector, and mostly they are there as additives in plastics. The three sectors make a relevant share of the overall use of plastic worldwide. Approximately 30% of plastic production is used in these three sectors. When we consider that these sectors have a relatively long service life, then more than 50% of all plastic stocks are contained in these three sectors, and therefore they are highly relevant for plastic management and recycling. So therefore, POP inventories and management can be linked or better require an inventory and management of plastics in these three sectors and an overall inventory of these three sectors. So from the three sectors today, when you look to the global landscape, we have only the assessment of e-waste, which is well developed by international activities, especially here by the Global E-Waste Statistical Partnership, which has the objective to improve and collect worldwide e-waste statistics in an internationally standardized way. So here the Global E-Waste Statistical Partnership assists countries in compiling e-waste statistics that are useful for national policy making using internationally recognized harmonized measurement frameworks. And you might know their reports, the Global E-Waste Monitor, but there are also regional e-waste monitors, and they have country projects with country-specific reports. What is highlighted is when you look here then to the management, only 17% of all the e-waste globally is verified as having been collected and recycled, while more than 80% is unknown. For the inventory and sound management of major industrial POPs, but also plastics, a robust inventory and environmentally sound management of electronics, electronic waste, but also end-of-life vehicles and construction and demolition waste is a key basis. So we, from Stockholm Convention, our work linked the robust national statistics to the electronic and e-waste work of UNITAR, with Stockholm Convention POP inventory work with the aim to contribute to the management of POPs. The Stockholm Convention guidance suggests that this should also be used for inventory and management of related resources, including plastics. So when we develop POP inventories today in these sectors, we also develop plastic inventories. But also metals should be included there, which are not yet. Why? Because metals are the key drivers for the management of e-waste, but also end-of-life vehicles. When you look to e-waste globally in 2022, the overall value of metals within e-waste was more than 90 billion US dollars. When you look to the total collection and recycling rate, only 28 billion worth the metals has been recycled. This means less than a third. So here, robust inventories of electronics and related metals could facilitate awareness, recycling, and recovery. So what is the approach or our approach for these inventories? Also the approach of UNITAR. So here, the import and export data of all electronics, which is available from the UN Comtrade database, is compiled of the last 20 years. And then taking service life function, for individual electronic categories, material and substance flow analysis can be developed for all countries. And here, when you look, there are in total 54 groups UNITAR made, so-called UNU keys, containing hundreds of HS codes, which is quite complicated to compile. So therefore, for example, the Basel Convention has proposed to use the 10 major UNU keys where electronics are included. And our approach for the POP inventories, we include 20 of these UNU keys, which from experience contain more than 75% of all electronics, plastics, and POPs. So by this approach from the Global E-Waste Statistical Partnership, information is available for all countries on the amount of e-waste generated for the years 2018 to 2022. I have put here the link. And these data can be used and compared with own statistics of countries and can be used for calculation of e-waste, e-waste plastics, and also be used for the estimation of POPs with our approach, which is described in the sectoral approach for POP inventories. Conclusions and future outlook. UNITAR and the Global E-Waste Statistical Partnership are compiling electronic and electronic waste data for all countries in the world. Based on this methodology, also inventory for plastics and POPs in electronics and electronic waste have been compiled for initial countries. We have published here the one for Nigeria, and it's also included here in the slides, the reference. For electronics, also information inventories for metals in electronic and electronic waste on country levels are needed to facilitate the recovery. And actually, this is the main driver. The Stockholm Convention guidance on national POP data suggests that such data should be available on the National Statistical Office. But what we need is actually some pilot projects for that. In the frame of the Stockholm Convention, also inventories on POPs and plastic for the transport sector and partly also for the construction sector are developed. So also there, now in our approach, we also inventorize the major plastics. And UNITA is currently developing a guidance for the inventory of all plastic in major uses. I mean, not only electronics and the transport and construction sector, but also, for example, packaging and textile. So this will be published most probably this year. This is for facilitating global plastic management. It would be interesting to cooperate with a UN agency, but also could be the World Resource Forum, working on resources and circular economy to extend the methodologies to metals to support countries to have robust metal, plastic, and POP pollutant data in these three sectors to support policy decisions for recycling and recovery towards a more clean and circular economy. Yeah, thank you for your attention.
Perfect. Thank you so much, Roland, for the presentation. I'm just checking whether someone from the audience wants to ask a question to Roland. You can put it now in the chat or in the Q&A. I don't see anything coming now. Maybe just a quick question from my side, Roland. You showed also in the case of e-waste the huge potential which is currently not yet tapped into, also in terms of economic value. And also the last key recommendation that you provided from a business and policy perspective, which is to key stakeholder groups that we're interested into at WRF, and we try to link science with. What is really the usefulness of having these inventories that are currently not there, and what other steps do you think are required to really make sure that we can take advantage of this huge financial potential?
Yeah, I mean, like I said, for Stockholm Convention, we are developing these POP inventories, you know. And when I was asked to write a sectoral guidance, actually UNEP first asked me only to write a guidance on POPs for these sectors. And then I said, that's not so useful. I also would like to include some other pollutants, major pollutants from other and also the plastics. And when I then wrote the second guidance on national statistical offices, you know, where I was asked that I should write a guidance where I highlight what kind of data should be available on national level for the POP. And then I said, okay, you know, POP is kind of waggling the dog with the tail. It should not be POP only. It need to be also plastic because it is highly relevant, and also metals because they are the driver. Yeah. And so I thought when we put these together, yeah, POPs, other pollutants, plastics, which is anyway kind of happening, yeah, that there is a driver from international conventions, then I think we should include also the main driver, which are the metals. And the advantage is, I think that first governments will understand what is the value, yeah, but also when you have these also, let's say, other stakeholders, like you said, the industry might be more aware, yeah. And not only that, today informal sector is taking out some of the metals, yeah, but of course they cannot take it out often in an appropriate manner. So therefore, I think if we compile this to a package, then it could make sense the effort.
Wonderful. Thank you so much, Roland. I see there is another question in the chat, but maybe we take it at the end as a more general discussion. Now I would like to give the floor to Namya Sharma from the Indian Institute of Technology, Bombay in India, who will be presenting on the development of city-level tool for circular and holistic construction and demolition waste management. Namya, please, the floor is yours and you may share your slides.
Thank you. I'll share my slides now. Good afternoon. I am Namya Sharma. I am working as a project research scientist in Indian Institute of Technology, Bombay, India. And today I will be presenting our work on development of city level tool for circular and holistic C&D waste management. And this presentation will be specific to Indian context. This work has been carried out in collaboration with Professor Pradeep Kalbar and Professor Salman from the same institute where I'm working right now. So we know that urbanization is a global phenomena, and by 2050, 68% of the world would be urbanized, which means that there would be an increment of 2.5 billion urban residents worldwide. For India, the stakes are quite high because urban development contributes to 60% of the nation's GDP. And as of now, we're still deficit of 19 million units of households in urban India. The development curve comes with a burden of sustenance. India is already the third highest resource extractor worldwide, and they are generating around 150 to 530 million metric tons of C&D waste annually. And if we go as per the business as usual text, then in the coming decade, we will not only extract the double resources what we're extracting right now, we'll also double the rate of C&D waste generation. So we know that C&D waste management is a pressing concern in developing countries, and therefore there is a need of a tool development to assist the urban local bodies or the state level bodies to identify resource efficient and circular frameworks for management of C&D waste. There's also a need for a platform for knowledge exchange as well as good practices exchange to propagate the framework of resource efficiency across the entire nation. Adaptability to regional growth characteristics, attributing the city level built area specifications in tool will also help in sustainable development. And any holistic circular economy framework should consider reduce, reuse, and recycle as three pillars of its framework in this consequent hierarchy to develop the most best possible and resource efficient framework. So, with this need, we decided to develop a city-level waste management guidance tool for the urban local bodies to include regional perspectives of built environment and future growth aspirations to support sustainable development of infrastructure in line with the C&D waste management guidelines. So the framework which we developed incorporated circular economy aspects from the purview of life cycle thinking. And we used a top-down approach where we identified a few cities in India and we attributed for the floor area in each city based on the national data inventory for city population and per capita floor area. Then, after attributing city level floor area, we demarcated the stock in permanent and temporary construction. And finally, we focused on this particular tool for reinforced concrete structures. And the building elements which were the focus of this tool were concrete and burnt clay bricks. These two materials were selected because they occupy the largest volumetric proportion in the built-up region of India. Then, using stock decay analysis and parameterizing as per Weibull distribution, we identified the outflow of the building material stock from each city. And based on this, we suggest through this tool nine circular strategies for C&D waste management for a particular urban local body or a city. Moving ahead, these are the inputs and the outputs expected from the tool. So if you can see, there are some mandatory and some optional inputs. However, if in absence of optional inputs, the state level averages are assumed, which might not give you that precise result as if you input the data for each locality or municipality level. Then the framework on which the whole framework is developed is divided into two aspects. First is intervention, and we propose three interventions for any city. First is design for disassembly for the upcoming stocks, which can be designed for disassembly and it can be dismantled later for use. Adaptive reuse is for buildings which are still in their use phase, where instead of demolishing, they can be used for a different purpose. And recycling is will be taken care by that aspect of of the stock, which can either be designed or it can be adaptive reuse. Again, for each intervention, we divide 3 levels of application, which is mild, moderate, and fierce. In mild, only 25% of the applicable stock will experience this intervention. In moderate, 50%, and fierce, all the applicable stock, a particular intervention will be applied. So using these 3 interventions at 3 levels of application, we devise 9 strategies, each varying for design for disassembly and adaptive reuse. And for recycling, C&D waste recycling is the last option allotted in this tool, where when both the option, when first and second, which is design for disassembly and reuse options don't work, then only that part of the stock will be recycled. And as an outcome, we propose 9 strategies and projected recycling units required in a state. So this is a short demo of how this working looks like right now. So you can see here that each city, we can choose the city which we want to use this tool for. And we have, this is the database of the cities, it can be expanded. Then for each city, depending on the type of structure they have in common, what is the average lifespan and what is the target C&D waste management. Then what is the per capita floor area? This can be taken at district level or at state level or at city level, depending on data availability, which is a major concern in developing countries right now. Then among the available floor area, what percentage is Pakka housing, Pakka as in which are permanent structures and non-permanent structures. So here you can see the inputs are being given manually, potentially by an urban local body professional. And then what is the percentage of permanent buildings, that also needs to be given input, and correspondingly the input parameters which you can see on the right will change. And what percent of permanent houses reinforced concrete structure will also be needed to finally suggest the strategies for C&D waste management. Now we propose this tool and we integrate circular economy principles with life cycle thinking, and reduce measure can be more focused in the first few stages, which is design and planning and construction stage. Reuse can be focused in use and operation and building when it reaches its pre-demolition stage. And when the building is demolished, the waste can be recycled and used as a construction material in future constructions. In this way, we can see that if we expand our thinking and to other measures of C&D waste management apart from recycling, we can ensure more flow of material within urban spaces. And the onus of C&D waste management will not come just on the buildings which are going to be demolished, and we can take care of it since the very beginning, since the very design and planning phase of building. In this perspective, we reimagined our cities where each building or each building in any stage of its lifetime plays a role in C&D waste management. And we focus more on design and disassembly and design stage interventions to promote circular economy in a city. So to conclude, we developed a citywide tool which considered regional building characteristics and growth aspirations, and it can give you a customized and more implementable C&D waste management framework. It is easy to use, and it promotes reduce and reuse strategies in C&D waste management. Encourages a perspective shift from C&D waste recycling, and it defines regional strategies to achieve national goals. So I would like to end my presentation here. Thank you for listening. I welcome questions.
Wonderful. Thank you so much, Namia, for the very interesting presentation. I'm just checking whether there are some questions coming from the chat or the Q&A. While I wait for that, maybe one question from my side. This seems to be an extremely interesting and especially impactful tool, given the negative impact the current construction demolition waste management has around the world, and of course also in developing economies. My question is whether you have already conducted or you are planning on conducting pilots with cities to see how the tool can really be applied, and maybe what kind of interventions can it inform?
So this tool has been developed for a particular urban local body using some bottom-up accounting analysis. However, we are trying to expand it to other cities with different built-up characteristics. So that is currently in progress, and we are also trying to make this tool more applicable. We are conducting more trainings. We are conducting more stakeholder interactions to understand how can we improve this tool and make it more relatable or more practicable for urban local bodies. So yes, pilot scales are in pipeline, pilot scale projects, and we are looking forward to it. We are talking to municipalities for implementation.
Perfect. Thank you so much, Namia. So I understand
Thank you.
also it will be a tool with the ambition to become as applicable and universal as possible. Thank you so
Sure,
much.
sure. Yes, yes. Thank you.
Wonderful. If there are other questions, I see maybe something came from the Q&A from Betsy. Maybe it's also something that we mentioned now, but in case you can also either answer in the Q&A, Namia, or we can take it up later in the discussion part. Now I have the pleasure of giving the floor to Luciana Contador from SETEM Brazil. I will be sharing the slides. And then, Luciana, please take the floor for your presentation.
Good afternoon, everyone. I'm Luciana. I work at CETEM, Center of Mineral Research in Brazil. Today I will present an overview of Project Recupere on the potential of urban mining in Brazil, focusing on recovery of critical minerals from e-waste. Next, please. Next slide, yes. Brazil is a geologically rich country with vast mineral stocks. Many of these include critical and strategic minerals such as copper, nickel, and rare earths and graphite. In addition to natural reserves, Brazil also holds significant anthropogenic stocks. As the global fifth largest consumer of electronic equipment, second in Americas, the country generates large volumes of e-waste. This makes Brazil highly promising for urban mining. Next, please. In Brazil, the management of e-waste is guided by a solid legal framework. We have here I bring for you three key mechanisms. Share responsibility is a concept from the National Solid Waste Policy. That means that manufacturers, importers, distributors, retailers, consumers, and government all share duties for the life cycle of a product, from production to final disposal. Second, the reverse logistics regulation for e-waste establishes specific collection targets. And third, Brazil is implementing a reverse logistics credit system that introduces traceability mechanisms and support transparency and compliance. Overall, these legal instruments create a foundation for urban mining opportunities. Next, please. The reverse logistics systems for e-waste in Brazil follows this structured chain, from collection to final recycling and reuse. It starts with collection, which is carried out by logistic companies, collection programs from government and from production associations, and formalized e-waste collector organizations. Once collected, the e-waste goes through a sorting and pre-screening phase. At this stage, the materials are directed or to reconditioning and remanufacturing, or to demanufacturing and recycling for material recovery. An important part of this system is the network of CRCs, Computer Reconditioning Centers. These centers are government-established electronics remanufacturing facilities that play a triple role: resource recovery, technical training, and digital inclusion by reconditioning and redistributing usable devices. Products and components that cannot be repaired or reused are sent to the manufacturing facilities for material recovery. At this stage, two main techniques are used: non-destructive techniques that allow more precise separations, avoid contamination, and lead to higher quality fractions, and the destructive techniques that enable high volume processing but demand technology for automatically separating shred materials into different categories. In Brazil, the most common recovered material fractions include metallic fractions, such as iron, steel, copper, and aluminum, plastic fractions, and printed circuit boards, which are usually exported. In addition, Brazil has begun to develop capacity for recycling lithium-ion batteries, photovoltaic panels, and now we have an emergent plant under development for the processing of permanent magnets for rare earths recovery. Next, please. Based on e-waste volumes generated in Brazil, we can estimate the potential quantities of metals that could be recovered. These are categorized into bulk metals, other metals, and precious metals. And from these estimates, we can demonstrate that urban mining in Brazil has a strong potential. Next, please. As Brazil reverse logistics systems for e-waste continues to grow and consolidate, we are also observing a rise in transboundary movements of e-waste, mostly for material recovery processes. Purpose. A portion of the collected and pre-processed e-waste is being exported to specialized facilities abroad. We can indicate this trend by looking into the increase in Brazilian exports under HS code 854929 that refers to waste and scrap used for recovery of precious metals. These exports typically include printed circuit boards, gold bearing components, and other high-value fractions that require advanced metallurgical process to metal recovery that are still limited in Brazil. While this export activity helps to enable the recovery of valuable materials and prevents landfilling, it also highlights the need for local investments in refining and recovery technologies, especially for critical and strategic materials. And in the future, improving domestic capacity could help retain more value within the country, create green jobs, and reduce dependency on foreign processing infrastructure. Next, please. The diversity and high volume of e-waste generated in Brazil represents an important source of strategic and critical minerals for anthropogenic stocks. The recovery of these materials can contribute to the supply of highly demanded minerals, for example, to energy transition. We have some successful cases of circular economy provided in the aluminum, copper, and steel value chain. We have companies such as Gerdau, Alcoa, CBA, and Nexa that are recovering and including secondary material in the supply chain. And finally, in Brazil, we have electronic invoices that are well established since 2006, and they are applied to reverse logistics systems, providing high-level traceability. And the new e-waste HS coding, globally implemented from 2022, are also fostering the urban mining traceability and reverse logistics systems by correctly identifying the e-waste stream. Next. Well, we are now conducting the Recupere project with the aim of evaluating circularity routes and potential for value recovery through urban mining of e-waste. And we will also have an international seminar on e-waste in October. So it's a city. I would like to invite you to join us. And thank you very much for your attention. I'll be happy to take any questions now.
Perfect. Thank you so much, Luciana. I'm checking if there are any questions coming through the chat or the Q&A. I don't see anything as of now. Maybe one quick question from my side. You mentioned you showed us a little bit the process for the recovery and the collection of the e-waste. And you also, one of your conclusions was really about increasing investments, domestic investments in the refinement and recovery technologies. But of course, urban mining has many challenges, no? In every part of the world, still from different steps of the process. What do you think would be key actions from a policy level to really improve this capacity domestically alongside the investments that you mentioned before?
First of all, I think we need to think about traceability because as Roland was saying, the metals are the key drivers because metals is where we found values to support the logistics system. And we have to know for sure where the secondary metals are coming from. Because if we don't have this kind of traceability, what occurs is that the metals are recovered and the plastics are left behind for landfilling. So I think one of the top issue that we have to look for is how to trace the secondary material, and of course some instruments to punish when these materials are not proper being directed to final disposal.
Perfect. Thank you so much, Luciana. That's very insightful. Now, I have the pleasure of, if there are any more questions for Luciana, please put them in the chat or in the Q&A. Now I have the pleasure of moving to Luciana Mofati, who will be presenting on Brazilian reverse logistics credits and waste pickers formalizing in e-waste urban mining. So definitely relevant topic and perspective compared to the previous one. So please, Luciana, the floor is yours.
Nice to meet you all. I'm Luciana Mofati from Rio de Janeiro. Greetings from Rio. I'd like to thank this forum for the opportunity to present a small part of the research I developed in partnership with the Center for Mineral Technology, CETEM, with the support of Lúcia Xavier, and the State University of Rio de Janeiro with Mônica Marques, which resulted in my doctoral thesis in environmental science. The work is entitled Brazilian Reverse Logistics Credits and the Waste Pickers Formalizing in Waste Urban Mining. Let me see. Okay, I cannot. Okay. Urban mining is the idea of extracting valuable materials from waste, much of which would otherwise go to landfill or incineration. As you can see, it requires collaborative reverse logistics system to accomplish legal requirements and to provide environmental and economic benefits. As Luciana Contadora explained before, we are walking through the create a national tangible or traceable system in Brazil. And in this way, it's possible to consider the concept of social innovation. We have lots of new keywords for circular economies in urban mining process as traceability, closed loop supply chain, classification of those new products, product passports, return to merchandise authorizations. Here in Brazil, platforms are connect cooperatives and municipalities, representing just one example of this social technology we face here. Also, the Brazilian government recognized the importance of inclusive reverse logistics and has taken measures to support its implementation. In 2024, the Public Ministry of Labor and the Federal Public Defender's Office drafted a joint technical note listing all Brazilian legislation that interface with the promotion of decent work and the activities of recyclable material collectors. The Axis 5 of the National Plan for Circular Economy, which promotes interfederative coordination and the involvement of workers in the circular economy, also proposed actions to incorporate informal workers in the circular value chains. Brazil adopts the goals of SDG number 8, which embrace the promotion of sustained, inclusive, and sustainable economic growth, full and productive employment, and decent work of all. And in 2024, ISO launched the Circular Economy Standards family, including ISO 5914. And the standard kept the value recovery system flow as shown in this adapted image. In green, you can see that value recovery system related to substance and less formal activities are most based on these manual activities. And in the earlier stage of the processing, such as collecting, disassembling, and sorting. And Brazilian domestic waste reverse logistics system regulated by a national decree, as Luciana told you before. The decree includes waste collectors, organizations as the logistic operators, and requires formalizations level of those organizations. As you can see here, Brazil is a continental territory and the second largest waste generator in the Americas. And then the National Waste Pickers Movement estimates that there are currently over 800,000 waste pickers living in subsistence conditions here in Brazil. The waste generation is spread all over Brazilian regions, but it's concentrated in southeast of Brazil, mainly in São Paulo. Waste collector organizations present levels of formalization. We, as you can see here in the image, is there a pointer? I don't know if you can.
Yeah, no, we see that. We see that.
Okay, this is the visit we made in this recovery project. It's possible to see levels of formalization. Okay. It's today we have more than 320 waste collector organizations dealing directly with waste in Brazil. Informal collectors organizations are spread throughout the country, whereas recyclers tend to be concentrated in southern and southeast regions. Brazilian regulation of reverse logistics credits also guarantees traceability. Our national invoices categorize scrap, and the transport control system on the right allows for the classification of destination mass. Together, those instruments provide the certifier with the total formal amount of the equivalent mass of products or packaging subject to reverse logistics and recycle, at least everything formal. This image presents a proposed scheme for the application of the regulation for reverse logistics system. The reverse logistics system is operated by PROs, company management entities, verifiers, waste collectors, organizations, and other kind of operators. On the left is how the decree creates a traceability system. Recently, we have ANCAT, the National Association for Waste Collectors, has become a national management entity. It increases the traceability among those entities. And on the right, there are three categories of credits. The first one is a market credit, purely based on document issued by the managing entity that proves the return to the production cycle of the equivalent mass of products, and also the final destination. The others are related to social indicators. The managing entity must certify that companies hold structuring projects based on or related to collectors' organizations, also in the view to the recovery of recyclable materials, and prove the return to the production cycle and the final destination. And CMF is the Future Mass Credit Certificate. It's a kind of a fund, a document issued by the managing entity that allows the company to obtain and advance the fulfillment of the reverse logistics goals in the subsequent years. And these logistic operators provides annual reports to the managing entity. And those annual reports are published in this platform named Senior, a national system or a national I forgot the full name, but it's our national system to traceability and where you can put the reports. And that's it. So I believe that this is the kind of national system which can brings more traceability in and be more inclusive to those informal activities. This is our preliminary group, the research group. You can see the informations in the QR code.
Perfect. Thank you so much, Luciana, for the presentation. I'm checking again in the Q&A or in the chat whether there are some questions from the audience. I don't see anything coming up now. Maybe then a question from my side, Luciana. This is, as you mentioned, a very important and significant topic, also due to the livelihoods at stake and the economic and sustainability potential of having more formalization and more inclusion in the whole electronic waste recovery. Apart from some of the solutions that you presented here, what do you think are steps that would bring closer, either through public intervention or also through public and private partnerships, that would bring informal workers more at the core of the value chain, able to really add value to this activity and increase their livelihoods as well?
Our system is based on these national entities, which provides the annual reports. So we have a waste collector association. Being a national entity is a great step for it, and do more transparency. This senior platform should report all agreements we made on the other products as plastics. As Roland told us, plastics is the main challenge, and Luciana confirmed nobody wants the plastic. Maybe to put in this national platform could give more visibility to the issue.
Perfect. Thank you so much, Luciana. I'm aware of time. We're a little bit over time. Maybe we just check if there are a few more questions coming from the audience. There was one, Roland, that was put forward during your presentation, actually, from Rainer Eitzinger, who asked how much of the recycled materials are actually reused in production as secondary materials. I don't know if you want to provide, if you have some numbers for some of the materials that you mentioned.
No, I mean, not really. I mean, for the metals, they are recovered and they are reused then, let's say 100%. And I did not fully understand the question. I mean, if it was for when you look to e-waste, 17% is, let's say, kind of recovered officially, yeah, more than 80% not. But when you then look also to the metal around, it's estimated that a third overall is recovered and reused. So for others like plastic, I think we know that it's for sure less than 10%, yeah, of e-waste plastic. For e-waste plastic, probably less than 5%. And also when you look to plastics in buildings, I mean, there I would actually have a question to Dr. Sharma. Yeah, in Germany we had our first project 3 years ago, to evaluate what kind of recovery and recycling could be done of plastic from housing. So I think this is currently the stage. I know there is a pilot. There's a project in Austria. They are recovering partly plastic from pipes and recycle them. And also in Switzerland, there is an activity of looking into pipes and the recyclability. But I think there it's at a very early stage. When you look to end-of-life vehicles, there is quite interesting current activity in the EU, because before, the recycling of plastic from end-of-life vehicle was also very weak, but now Europe changed to the regulation, and they are actually requiring for new vehicles that the recycling content of plastic should be 20% in future. So this will make a big change in respect to recycling of plastics from end-of-life vehicle. But like I said, the regulation is now not finalized. It was in commenting. They reduced from 25% to 20%, but it is upcoming. Yeah. So now, Dr. Sharma, to you.
Yes, thank you for the information. If I talk specifically about the construction sector, then most of the plastics which we obtain from the debris is recycled or it's reused for low-income households. So if we talk about PVC pipes, for example, they are used by low-income households, and they have a good market, good economic value in the secondary material market. So in India, especially, if I can say so, there is a thriving secondary material market for construction and demolition waste. And the business perspective which drives demolition contracts is the metal which can be retrieved from the debris. So in India specifically, our pain point is not metals, if I may say so. The problematic aspects are metallic portions of the CND waste, which is the brick and the concrete part, which is most likely to be, discarded or disposed of in unauthorized locations, because our landfills are already full and there are a lot of levy charges. So metals, and we also have some good brass or things like that, or even plastics, or even wooden doors or wooden frames. They have a good secondary material market. Obviously, the quality in the second life is compromised. There are no regulations which monitor the manufacturing of secondary materials from after its first life usage, but they are still in use. So I will look into the projects which you mentioned. So maybe we are looking for pilot scale projects at urban local bodies, but starting from a building level will be a good point. Thank you.
We got to the end of this session. I wish to thank all the panelists for being with us today, for the very interesting presentations, which I think provided a breadth of perspective, but also very much cross-cutting and overlapping insights. So I want to thank all of you, also on behalf of the World Resources Forum, the audience that was with us today, the interesting questions, and looking forward to the next steps that will come out of your research. Thank you so much, and see you the next time.